Unit 4, Day 5, Rationalizing the Denominator. Last week we talked about the techniques for division with radicals. However, there is one thing that we did not talk about, and that is called rationalizing the denominator. Let's say you work out a problem and you finish everything you think is done, and you're left with 3 divided by the square root of 2. In mathematics, you are not supposed to have square roots in the bottom of a fraction. So this square root of 2 we have to get rid of somehow. Well, let's think about a technique we could use. Let's multiply it by itself. Square root of 2 times the square root of 2 should turn into something nice. However, we can't simply multiply by the square root of 2 on the bottom. Let's multiply it also on the top. This is the equivalent of 1, so it really doesn't change anything. However, let's look at what it does to the look of our problem. Multiplying denominators, we get 3 times the square root of 2. Multiplying the bottoms, we get square root of 2 times 2. As you recall from last week's work, when you have 2 numbers under the square root, those simplify and come out as 1 of those numbers. So the square root of 4, in other words, turns into regular 2. The numerator looks like 3 square roots of 2, and because there's no longer a square root in the bottom, this is considered to be done. It's rationalized. Example 2. Let's say we've got a cube root, like the cube root of 6 divided by the cube root of 9. Now, these are cube roots, so we need to have 3 numbers that are the exact same before we can simplify things. So using the idea, it's going to look like the previous one, where we have another cube root, and it will have a 9 in it, but it's going to actually have 2 9s. So that when we multiply all these together, we'll have 1, 2, 3 9s under a cube root. That will allow us to do some factoring and canceling. Just like before, we can't multiply the bottom by something and not the top, so we have to multiply the top by the same exact thing. Now the bottom will look like the cube root of 9 times 9 times 9, which is good. The top will look like the cube root of 6 times 9 times 9. The bottom should be fairly straightforward. As you remember from last week, if there are 3 of the same number under a cube root, it comes out as 1 of those numbers. But we need to work on the top. So let's come down here, there's a little more room, and look at the cube root of 6 times 9 times 9. Let's factor this and see if we can find any things that are the same. 6 is 2 times 3. 9 is 3 times 3. And the second 9 is 3 times 3. So, again, because this is a cube root, we're looking for groups of 3. This group of 3 will simplify, and what's left is 3 times 3 times 2, which is 18. So, this now becomes our numerator. And there's one last thing we have to remember. You always want to look for chances to simplify. Here's a 3, here's a 9. Let's reduce those to 1/3. Our final answer is 1 cube root of 18 divided by 3. We're going to do 2 of these last kind of problems. They involve the technique of foiling. Let's say you have a fraction where the bottom is a binomial. How do we cancel out 3 minus the square root of 5? We have to take care of that because, again, there's a square root in the bottom. We need to do something called multiplying by the conjugate. And the conjugate, if you have 3 minus the square root of 5, that simply involves changing the sign between them to 3 plus the square root of 5. The plus is going to interact with this minus when we FOIL, and it's going to make a difference of 2 perfect squares, which is actually going to be pretty nice when it's all done. So let's multiply by the conjugate and see what happens. I'm going to write the answer down here. So put parentheses around everything. That's a binomial, just to remind myself to distribute. 6 times 3 on the top makes 18, plus 6 times the square root of 5. There is no interaction with the square root numbers and the outside numbers, so this is all I get. The bottom, however, is going to be pretty cool. Let's FOIL. 3 times 3 makes 9. 3 times positive square roots of 5 makes this. Negative square root of 5 times 3 makes this. And finally, negative square root of 5 times positive square root of 5 makes negative 25. Now these middle terms cancel out. The conjugate creates the difference of 2 perfect squares. If you notice here, we have the square root of 25, which is really 5. So, cleaning things up a bit just to look at what we've got. On the bottom now we have 9, the middle terms are gone, minus, and I'm not going to write the square root of 25 anymore, I'm going to write that as 5. So, simplifying one more time, 18 plus 6 square roots of 5 over 4. Now, before you think you're done, you should always look at everything and see, is there a greatest common factor I can get out? And because these are all even, I can divide everything by 2. So I'm going to divide everything by 2. So my final answer will be 9 plus 3 square roots of 5, all divided by 2. Our final example involves a binomial denominator and a binomial numerator. Not a problem. We just have to remember to multiply the bottom and the top by the same thing, and that thing is going to be the conjugate. I take the bottom, and instead of minus, I put plus. That's going to create a difference of 2 perfect squares on the bottom, and that should take care of the bottom. The top may be a little weird, but that's okay. Remember, we are going to use the FOIL pattern to distribute. So I'm going to put parentheses around everything to remind myself of that. So here we go. Let's do the top. Square root of 7 times the square root of 7 is the square root of 49. Square root of 7 times 2 is 2 square roots of 7. 1 times the square root of 7 is 1 square root of 7. And finally, 1 times 2 is 2. That's the top. The bottom, 7 square root times 7 square root is square root of 49. 7 times positive 2 is 2 square roots of 7. Negative 2 times square root of 7 is negative 2 roots of 7. And finally, negative 2 times positive 2 is minus 4. Again, let's notice that on the bottom, these cross out. Everything should be pretty tidy. The top, we don't have to worry about if they're square roots or not, but the bottom can't have any. And if you'll notice, the square root of 49 is really just the number 7. So I'm going to clean this up as much as I can. In the top, I have square root of 49, which I'll write as 7. I have 2 square roots of 7 plus 1 square root of 7 makes 3 square roots of 7, and then plus 2 at the end. All over. The square root of 49 is 7 minus 4. So let's see what that turns into. Again, we got to do a couple more steps of cleanup. In the top, 7 plus 2 is 9 plus 3 roots of 7. Clean those numbers up. Over 7 minus 4, which is 3. What should we always look for when we think we're done? Greatest common factor, and that is 3. So let's divide every term by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 3 divided by 3 is 1. So our final answer is not what you expect. It's 3 plus 1 square root of 7, and we are done.